Hello students. Today we will do this question. This question was asked in 2025. Okay. This is not a very difficult question, but you have to understand couple of things properly. Then only you will be able to do the question. Okay. जिसने भी second option लगाया है, that means that student did not read the question properly. Okay. And second is not correct by the way. Okay. So coming to this circuit diagram, this is the figure that you are given, and until and unless you understand this, this is not just a full wave rectifier. This is something called center tapped full wave rectifier. Okay, center tapped full wave rectifier. Okay, so you have to understand the meaning of center tap, what it means. Basically, what you do, somehow when you give some AC input basically, and you have this as a transformer, so secondary coil of the transformer is made in such a way that this coil is divided into two sets of coil, and the purpose of doing that is to divide the voltage into different sign in a way. Okay, two different polarity. Okay, so let's say this is, by the way, AC input. That means for half of the cycle it would have a positive polarity, and another half it would have a negative polarity. Okay, so even in that, secondary coil will give you two sets of polarity. Okay, so for example, if let's say this center tap was not there, okay, but in your books this is how you may have seen. Okay, so this is your RL. Okay, and this is how, this is also another way of representing it, the way it was given in the examination. So if it was not center tap, what would happen for half of the cycle? Then what you can do, d1 and d2 you have to place it in an opposite way. Okay, so for half of the cycle d1 would give you output, and for other half of the cycle d2 will give you output. But here d1 and d2 are has been kept in a same, has been connected or kept in a similar fashion. Okay, so to do that, this center tapped thing has been used, and it is going to divide this output. If secondary coil is given negative, so this is going to be negative, other half is going to be positive. And if secondary coil you are in the first half of the cycle, this is going to be positive and this is going to be negative. Okay, but you have to understand, when you are asked time t is 15 milliseconds, so before that what you do is you have to find out time period. So time period would be what? Omega t, that is omega is 100 pi. Okay, omega is 100 pi, and omega is what? 2 pi by capital T. T is, time period is 0.02 second. Okay, little bit of disturbance, I'm going to finish it very soon. Okay, time period is 0.02 second. So sine wave, half of the cycle will finish in what time? 0.01 second, and other half of the cycle will be finished in what? Another 0.01 second. But when you have to find time is 0.015. So that means you are in the second next half of the cycle, and in the next half of the cycle, first part will have negative and second part will have positive. So this negative, okay, so this time will tell you whether you are in the first half of the cycle or whether you are in the second half of the cycle. So time period is 0.02 second. That means you are in the second half of the cycle. You are somewhere here, right? Half of the cycle will be 0.01 second. So here the secondary coil will divide this into negative, similar way, whatever it is, but the rest, other half will have just opposite polarity. So this will be in forward bias and this will be in reverse bias. Which option is correct? So D1 is in reverse bias and D2 is in forward bias. First one. But let me tell you what. So you are giving input something like this, right? So what is the output? You will be giving, you will get this output, okay? Either way, in the first half, D2 will be working, and in the, in the first half D1 will be working because D1 will be positive, and in the second half D2 will be working. So the purpose of this full wave rectifier is to convert AC into DC, where do you use it? Basically DC power supply. You connect it with the AC supply, but you get DC power, constant voltage. But do you think this is constant voltage? Okay, pause the video and try to understand how can you get this voltage as a constant. So you have to apply some sort of filter, and that filter can be a capacitive filter. So it will be charging so that a constant voltage can be given as a output. Okay, so voltage time. Okay, so you can use a capacitor after this, and you can have a constant voltage. Okay, so thank you so much for watching the video. Thank you.